Julian and I, this is our fourth Tech Field Day event, actually. So he has been the hacker, and I've been the defender with our Fortinet products. So if you go back onto our Tech Field Day YouTube channel, he actually hacked my juice shop, which is a OWASP vulnerability application. He ordered tons of juice there at that time when we presented. And post-COVID, all of the shipping rates went high, right? So I started my own drone company, or actually for shipping stuff. It's called Cyberspace Force, and that's my application page. That's my website. So I'm going to use my drone to deliver this juice to everyone, or mainly Julian. So I'm going to see what you can do this time and what you came up with. All right.
It's yours. And Srija, just by the way, that drone thing, I think it's cool, but I bet it will not work this time.
We'll see.
Let's try that out, yeah. So I've prepared something for you.
Yep. Okay. So I'm also ready, but let's start the demo. Yeah. So this is our, I'm running a drone script here to start the drone. It's going to run this one, so I'm going to fire that.
And I've prepared something little for that. Let's give it some time. And Srija, I'm sorry for that. That didn't work out well.
Sorry, guys.
Bummer.
Yeah.
But it landed right there.
Yep.
So it's not like the toast, right?
So you're back of my drone now, right?
Yeah. So maybe I will start our drone business. Let's see for next year.
Okay. So
before we jump right in, I mean, it was a lot of fun, to be honest. It was a very short demo. Sorry for that. We can fly the drone later again. We have some more battery packs here for that. But so it's about the impact. So, right, we all have that autonomous systems. We have the OT systems. Everything starts getting controlled autonomously. Thinking about, for example, Amazon having the drone delivery, which is indeed a pretty cool thing, I think. And it's definitely future-proof. But it also has its risks. And think about you walking down the street and suddenly you get hit by a drone. You didn't see that coming because it's miles away from you usually. And that's exactly a risk. So we tried to exactly simulate that. And just again for the attack path. So I'm that guy with that black eyes here. And so what I did, basically, I know there's a FortiWeb somewhere. There has to be a reverse proxy. I don't know what's configured there. And what I did is I was attacking that application. Srija, how is that application built?
Yep. So just to go over a little bit about the application and how this is deployed, right? Our FortiWeb is a web application and API security firewall offering from Fortinet. It's deployed in Azure, like Aidan mentioned before. And the application, it's deployed in Kubernetes on a native Kubernetes cluster. Just a simple web application there with a Flask API. That's what it is doing. And then how it is actually working with FortiWeb is with the FortiWeb ingress controller. That is our ingress, a piece of ingress from FortiWeb, which is more a FortiWeb agent. And the cluster or the application, the ingress is exposing that service. That's how I was able to reach that web page before. It's more connecting to the middleware. That's how the drone was up there and running. And Julian actually tried to hack my app there, right where the drone went down. So what was actually configured? Since there is FortiWeb, I want to share my screen for a second. And I want to see why FortiWeb wasn't able to block that in first place. So
and maybe to add, that application, it's completely custom. So it's custom written. There is some sort of API documentation, to be fair, but I missed a lot of those parts where we're writing that on purpose. So it was really made to be fully fledged custom, like in a real world environment. And yeah, if you look onto that, and what also happened in the background, I think Srija, we can also tease that already.
Mm-hmm.
We got some messages out there to some people. So right in the time where we showed you the diagram on purpose, we needed about that minute, sorry for that. We sent out emails to the SOC. They're informed to do something. And you will see that in just some minutes. And even the developers informed. Even there is a Gish issue open on GitHub. And everything happened in less than, let's say, about a minute. And that's about the security automation piece on that part.
So why FortiWeb? Because it's a web application and API security firewall. Why I didn't block it? Because this is a policy where we configure protection profiles. And the reason it didn't block is because it's in the monitor mode. The monitor mode is just to monitor and generate an attack log, but it's not actually blocking those attacks because this is a production. It's not a production app. I just onboarded it and Julian caught right in time and he attacked it. But this could happen in a real world scenario, right? We onboard the apps, we are testing, it's in monitor mode. This might be a staging application, but somebody is actually looking at your app and is still hacking or attacking these. So that was the reason why it didn't block it in first place. But going back to the GitHub issue, like Julian mentioned, because of another piece of automation called FortiSOAR, security orchestration, automation, and response, that's a FortiSOAR product from Fortinet. Because of it, it opened a GitHub issue because this is where the developer have this code for that web page. It automatically opened right now, right? There is a security vulnerability. Click on that. It says there is some malicious activity. There's machine learning module on FortiWeb that has triggered the attack. It figured out that it's an open API request body violation, and it's of type command injection. That's what the message shows. So it's all written in this GitHub issue. So the developer knows that what to go and fix in the code. And not only that, this is our 40 mail, too many 40 products, so I'm not going to stress on that. But the whole thing is that it's a corporate security email. So I'm now being a SOC analyst, right? I received this email where it's also telling that there is this security vulnerability, code injection attack detected. And all of this information about the payload, the address, and rest of so much information. Now there is also one thing right now. I'm busy in between this presentation. I cannot go and fix those things. So what I need to do is take an action right away. So I have this is another automated email. I say approval workflow. It's just telling me that there is a certain damage that had taken place. In order to prevent that further, right? I have to approve. Let me approve that, and then we'll see the result of this shortly, but I approved an action flow. I took an action because I'm in between this presentation. I'm busy. So Julian, we'll see what you can do.
Nothing. Literally nothing. I'm blocked.
Do you want to?
So it's up to you to dive into FortiWeb. So I am.
You can show that maybe when you
show. Can you stop sharing?
Yeah.
So if you try, it's not loading anymore. It's dead. So right in less than 5 minutes. If it's good or not to block that IP address, that's an open discussion. As a first aid, it's a good way. For sure, there are other ways, but we decided to go with that. But we have tons of capabilities. We'll show you later that when it comes to the security automation piece. And also how all those messages put together, because there was no human on that. Because the idea is you need an assistant in the security. But before we dive into that, you want to speak a bit about machine learning and how you were able to identify those weird attack vectors I was using?
Yes.
Great.
Just while that's coming up, that GitHub issue that was open there, was that integration from FortiWeb to GitHub for that specific application?
No, that's really through FortiSOAR.
FortiSOAR, sorry.
So really, FortiWeb basically detected the attack.
Yep.
And then it went further. You will see in the next minutes how and what exactly we did. And there's a huge piece of different chains of tasks, and we did evaluation on that. And is it really what it seems to be, or is it maybe false positive? All of that, we did all of these, and the result is yes, that attack exists, and we identified that application is hosted on that GitHub or that GitHub repository.
So that's something that you've configured as the architect who's created the application. You've gone and said, here's the repository for this app.
Yeah, for asset management purpose, for example, that we did a tagging on the policy.
Okay.
That it's that application.
Got it.
So that's it. And based on those information, we basically puzzled the pieces together at a central point, and based on that, we were able to identify that issue. We also, for example, would be able to identify who's really the exact developer, and going further on that.
Cool.
Okay, going back to the demo environment, right? Again, this is the simple setup we have, FortiWeb, or WAP, I would say. And then FortiAnalyzer, which is our analyzer connecting the logs from FortiWeb and ingesting the logs into the SOAR, which is our automation platform that we discussed. And the application is, again, hosted in Kubernetes, native Kubernetes cluster. That is also in Azure, just on a Ubuntu VMs running. And then FortiWeb is actually front-ending that application. So this is the whole setup there. So just to go over what FortiWeb can do, right? What are the critical use cases of our WAF is web application security, where we can do OWASP top 10 protection for application, because it includes known signatures, and also we have machine learning for unknown or zero-day attack signatures. And web application security and bot defense is something which we have already actually demoed here in our previous Tech Field Day events. That's where we demonstrated Juice Shop. So I'm not going to go over those, but it's more, we're doing web application security, and also for bot defense, we have multiple modules where we do threshold-based detection for identifying crawlers and scrapers, and also machine learning-based bot identification, where we are collecting information about regular user traffic and then determining if it's a bot or not in 10 different dimensions. So that's another feature of FortiWeb. But mostly the focus is, again, on internet-facing APIs, because we have seen APIs have become very critical to business applications. Even our phones run on APIs. So it's very important to protect these APIs as they add an additional attack vector, right? So that's what we are going to do, focus more on this here. And then it also, FortiWeb also has a feature for for alert fatigue, to reduce alert fatigue with threat analytics module, where threat analytics is actually grouping attacks based on common vectors using machine learning. So as an administrator, you're not getting this hundreds of attacks, but they're grouped for you already, so that you can only focus on what is important to you and then take action, just like we have done with SOAR. So either you could use this integration, or also take an action on the from the FortiWeb itself. That's another feature. So internet-facing APIs is our main critical use case now. So let's go deep into the APIs, right? We all know there are different frameworks for API. Most of us know REST API, but there is SOAP, which uses WSDL schema, or SOAP, right? And gRPC, which is Google Remote Procedure Call. It's a protobuf over HTTPS is the protocol it uses. And then GraphQL is founded by Facebook in 2012. That's another API. So what we are seeing is this different types of APIs exist, and that's how we integrate applications, either business to business or business to customers or consumers, right? That's what we are using these APIs, but the most common one is usually REST API, right? So what that means is you might need different platforms or different application security or API security firewalls in order to identify all these different types of APIs and protect. But with FortiWeb, what we have is we can do JSON-based schema protection, REST API or Swagger Open API framework schema protection, and also SOAP or XML schema protection as of today, and also gRPC. It's not schema protection, but we already added those gRPC-based web protection to our WAF. So either way, any API or protocol, you can do schema protection, and these are the common APIs that I wanted to show.
Can you just expand a little bit on schema protection there, around like Swagger, for example, like what's actually going on there?
Yeah. So I can show you visually again after, but now what it's doing is on the FortiWeb, if you have a schema for the documented APIs, right? Either it could be JSON or SOAP. As the developers document it, you can upload the schema to FortiWeb, and it will compare every request that is coming in with the schema file. So say username is a string and somebody is using a special character payload or something else, it will identify that it's not matching the schema, and it will block that request.
Got it. So it won't even let it through the origin.
Yes.
Yep.
Yeah.
Okay, cool.
And REST API anatomy, I know everybody is definitely aware of this, but just to go over, right, what does REST API call include is URL and method. URL is the endpoint URL where we make the request to. Method is get, post, delete, or whatever the RFC, HTTP methods, right? And the endpoint is the data, right? So it depends on what kind of data. If it's a post request, it has a request body. If it's a get request, it has parameters. Either way, either it could be query parameters, header parameters, body, or anything. It's still the data, right? That's how REST API anatomy is. So in this, going back to our attack previously, what we have actually done is, it's not a schema protection based identification we have done, but it's machine learning based API discovery feature that FortiWeb has. And that's what we have identified, that how it was categorized as an attack when Julian actually crashed my bot, my drone. And then how it triggered that it's an attack log, right? That's what it did. So how is with machine learning based API discovery, and why do we need API discovery, right? Few things are, again, APIs, lifecycle, microservices will have added a lot more internal APIs. And the other major thing is the shadow APIs, right? So we have schema protection when you have documented APIs. How about undocumented APIs? What we cannot see, we can never protect, right? What is not visible, we cannot secure them. So that's the shadow APIs, which are never documented. Why those shadow APIs occur is because developers might use these endpoints as part of the code, because they're just coding, and they might be using as later part of the code, but they're never documented because they think they're never exposed, and it might doesn't matter. But those actually add an additional vector, right? So hackers do use those shadow APIs and make sure they attack them. So that's very important for us to identify those shadow APIs as well. So we need someone else who is doing that job for us, because there is no documentation available for those in an open API framework or any other framework, right? So that's why we need API discovery. And how we are doing on FortiWeb is what I'm going to talk later. But this one, when we are doing this API discovery, machine learning based, we have certain challenges, right? And what those challenges are is, we have seen URL method endpoint, and then there is ambiguity in the URLs that we need to identify. Because if you see here, user/A, user/B, A and B can be static values, or they could also be dynamic values, right? They could be parameters that can be replaced. So that's something which we need to consider. That's one of the challenge when we're doing this API discovery. The next thing is the nested resources. So we see here arg1, B, arg2, C. arg1 and arg2, again, can be part of the static URLs, or they can be dynamic URLs floating there, right? Or parameters floating there. So there is this challenge we also need to take into consideration when we are building up this API discovery feature. And that's what FortiWeb is actually addressing. So FortiWeb does machine learning, which is API discovery. And how we are doing it is, this is some information, right? What we call like backdoor information. I'm just kidding. This is all GA. But what it is we're restoring the API specification by profiling the API samples. We are profiling the API samples as user traffic hits. And the second thing we are doing is, we need to also identify if these APIs belong to the same API or different API, because there is a lot of this user traffic coming. So what we are using is a clustering algorithm. What clustering algorithm is, it's a machine learning based machine learning algorithm. It's like unsupervised machine learning to clear out that challenge, right? It's more a ML to solve the unsupervised learning problem. And this is mainly used in data analysis, where there is a lot of different types of samples or data, but we use this clustering algorithm to group the data into one, so that they are of same type of samples or of same proximity. That's what the clustering algorithm is doing. But that is in general, right, in a machine learning, in a computer science world. And then we have what we developed is URL clustering with schema awareness algorithm, which is an improvised version. And then obviously from the leader clustering algorithm, that's on the next level of clustering algorithm. So we improvised another URL-based clustering, and we are just grouping these URL parameters based on like sample identification, and then we are building this machine learning model. So these are our modules, and this all happens on FortiWeb locally, and it is per application. So the whole summary is that it's the user traffic is coming. There is this pre-processing module running on FortiWeb, which is cleaning out this raw samples, putting together these raw samples, and then it comes to the inference module. And inference is, again, these are all pieces of machine learning, nothing new. But the algorithms we are using are something which are cooler and unique to FortiWeb WAF. So the inference module is where it's taking these samples, and then it's coming at a conclusion of what are the same endpoints or different endpoints. What does the schema need to be? And it will train the machine learning model. and it will give us a security scores to identify, if it's an alert or a block. So I'm going to go back to FortiWeb here really quick. And if we go into the log access and attack, this is the attack log. And we see, right, this is Open API request body violation. That is what the alert is. And see all of this information. This is what Julian used for command injection. And we see the raw body of what actually he used and few information around it, right? And this is our API protection, machine learning based API module. This is the domain of my application. I click that, there are different URLs that it has learned. And this is all machine learning, it's all automatic. And it also collected the samples. So as it reaches enough samples based on the clustering algorithm, all of that, it's putting together, it's combining that data and running this model. And then when we see there is this different tree view, like different views of what the information it has collected. And what is cool about this is, if you haven't documented these APIs, we are also documenting you as Swagger, and you can download this. So this is, again, everything is through machine learning, and this is per app built locally on the FortiWeb. So that's how we identified that command injection on this API is an attack. And we send it to SOAR, and that's where it triggered that GitHub issue.
So you don't have to import the Swagger for all your inherent APIs. You can just let it learn itself.
Yes, exactly. Yep. As traffic comes in, it will learn itself. Yep.
There a lightweight license of just this available for idiots like us who can't document our own APIs? This could be the greatest tool you've invented. The whole startup right here. What are you doing?
Yeah, and you guys, the FortiWeb is hosting this for my, like if I'm an external consumer of this API, and I go to view the Swagger documentation, is that actually coming to the FortiWeb and you're serving it off there for me as a consumer of your application? Or if I go to the Swagger documentation, is that still going through to like where my application's hosted?
Oh, this is local to FortiWeb, so you can export it, not import it, obviously.
Okay, but FortiWeb isn't serving this out to my external customers.
Yeah. So it's not actually not available, like, how you have a Swagger/Swagger for an API endpoint.
Yeah.
That's not being served like that.
Got it. That still go through.
This is literally on the FortiWeb that is running. Yeah.
But you can take that.
Yeah, you can host it there. Yeah.
But you have to do that step for
me.
publishing manually.
Got it. Yeah. Okay. And I assume you guys have got an API for this, so I could have something that grabs it from here and puts it where I. Yeah. Okay. Cool.
So this is the API protection module, like you were asking before. Sorry, the protection policy, the JSON schema, we can upload it, which we don't have right now, but because we are using completely a machine learning based API learning, but that's also a feature of FortiWeb.
Okay, cool. I've got one other question, if I can, just about the architecture of this. And a lot of what FortiWeb does from a protection defense perspective, some of the API management tools, so if I'm talking Azure, that'd be literally API management, or I think it's API gateway in Amazon. I feel like you guys do a lot of security stuff better, as you'd hope. Is the architecture still that if I'm developing an application, would I still have an API management service for like versioning and such of my APIs, or is it literally ingress into the, ingress comes into FortiWeb and then straight to my, application hosted on functions or containers or whatever it might be? Or is there still an API management component that would be worth having in between FortiWeb and my backend application?
Yeah. So if you go for different vendors, right, like RPG or API Gateway, they are more hosting the API. That's not what we are doing. We are more protecting the APIs, right? We are on the security side, front-ending those APIs.
Yep.
So you would still need some kind of management service where you want to host those APIs, but have this so that your APIs are not exposed and are being protected.
Got it, yeah. So instead of doing my subscriptions and user access and whatever on API management in Azure, I'd use you guys for all of that sort of stuff, and API management is simply doing like versioning and paths and stuff like that.
Yes.
Yep.
Yeah.
Cool.
Like ingestion of the Swagger, like a lot of companies dump them to an internal web page or something like that. Are you able to point to an internal directory and just have it flat out import all the time as they're doing code updates and stuff like that into the APIs?
Yeah. So what we can do is, I think I have tested this long back. I don't have a working demo, but so this FortiWeb comes with an API, right? Like FortiWeb itself has an API. So you can actually use that JSON schema endpoint into like a Jenkins pipeline, and then keep uploading the file as like the API file as the code changes, right?
Okay.
So we can do that with the API of this. Yeah.
Awesome.
In a perfect world, the developers are,
Oh no.
creating open API docs as they write that new API.
Yeah, everything is documented. Yes,
Yeah.
then yes.
I don't
If
even
not,
think the people that created OpenAPI document manually. Like that's no.
But that's why we can learn that.
Yeah, totally. Yeah, that's cool. Yeah.
It's in the testing phase, we can learn it, and then you can export it in for the production phase you already have.
Yeah. As Eric said, it allows us to be even lazier now. So that's cool.
So, hey, I have a question about the machine learning capabilities. Are you able to dump some of that information back into like centralized repository somewhere else and potentially share it with other customers utilizing this so that they could essentially see if there's a new attack vector that is coming down from a very popular application that somebody might be running in multiple different locations and multiple different customers, so that they could potentially head this off at the pass? In kind of the example that you gave with the drone, you basically were able to shut down that particular call to that particular API.
right.
What if that drone application was being used by more than just, say, Amazon and like Walmart or other delivery companies were using that same framework? Would you be able to share that information amongst multiple different locations so that you could shut down that attack vector immediately without having to learn the hard way by actually having to been attacked by it?
Right. So this machine learning based protection, right? What I'm showing right now is per app based and running locally per application. So that is unique to this application, right? So the signatures, this is again based on the traffic that has been observed. So why it actually flagged is, the calculator here, for example, this is more taking the just the integer values, right? So it does know that the values it has to expect, or the genuine values is going to be integers, but not something else, other payloads, right? So it built that mathematical model by looking at that 600 unique samples. So it learned that it's an integer, and it built that machine learning model. So that's kind of like for more unknown or 0-day attack vector, right? This is something. For known signatures, that's the case. So say these kind of signatures are flagged, and our FortiGuard team, have seen this as like a wide threat, then that would be uploaded to our FortiGuard service,
Right.
and that goes as long as all our FortiWeb, FortiGate, all of them are licensed, they get updated with those FortiGuard signatures. So the FortiGuard team is actually like a threat detection team at Fortinet. They receive about 5 million threats every week. So they compile signatures and they keep upload them to all of our customers. But this machine learning, which I'm showing, is per application and running locally on FortiWeb.
Yeah, just one more comment about that. So yes, I think part of your question is about globally sourced threat intelligence and how that is learned. So our FortiGuard threat intelligence services will take anonymized threat data from customers who are contributing. So there's no, we have a data privacy document that talks about that. But so things like services like FortiWeb or FortiGate will feed that information, and then we consolidate that at a global level to provide updates to signatures and even update the ML engines in some cases that are serving our products.
Thank you, Aidan. So just moreover, I wanted to share more in depth of how we were doing, and this is all about FortiWeb, right? And the API discovery, how we are again building that Swagger and all of those tree view, parameter view is based on 10 dimensions here. We are examining URL distance, if there are any changes, or Hamming distance, right? That's more in computer science, where we are relearning new parameters if the distance is large, and if not, then we'll just keep that and that machine learning model. But we're also learning about path parameters, HTTP method, all of these different dimensions, and we are building that machine learning model and protecting your applications there. So it's more an added advantage, not only for FortiGuard known signatures that run on FortiWeb, But it's more like providing an advantage, an additional layer of security, because we already have those known signature database that we talked about on our FortiWeb, but also providing you this machine learning, which is unique and more towards your applications, catering your application needs. Yeah. So the other thing is the ingress controller. So with FortiWeb, right, like I mentioned, this is a Kubernetes-based application that is running. So it does how we have this Kubernetes ingress controller. So just to go over ingress, right? Ingress is an API resource of Kubernetes where it is actually exposing the services on both HTTP and HTTPS to the users, right, to the outside users. And ingress is just more a resource. It's of no use without an ingress controller. We need an ingress controller, which is more a load balancing service, exposing again for SSL termination or host-based, path-based routing, etc. Right? So that's ingress controller. There are a lot of ingress controllers in the Kubernetes world. But with FortiWeb ingress controller, we have this WAF. You have great security, but how about making it easy for customers who are using this Kubernetes-based applications? So ingress controller can be deployed. That is developed by our FortiWeb team, our developers here, who actually is here in Sunnyvale. So they have programmed this, and you can deploy it with a Helm chat on your Kubernetes clusters. So it's actually being deployed as a pod in the Kubernetes cluster. It's an application running, and it will list and watch about these Kubernetes objects, which are nodes, services, ingress objects on the Kubernetes, and it will update FortiWeb, and it will also convert this Kubernetes related objects into FortiWeb related objects. Like on FortiWeb, what we convert the services to be server pools, because that's where it's being load balanced to, right? That is where we load balance back the traffic to. And then we need a virtual server to expose this in the FortiWeb world, because that's how the reverse proxy works, right? There will be a VIP, a virtual server, which is sending traffic to server pools. That's again, server pools in this case would be nodes, or like, the services that are being exposed in the Kubernetes cluster. So it's all converting that into FortiWeb based objects. And say something is deleted or created, because Kubernetes objects are highly ephemeral, right? They die, they get created. It's doing automatically. So we don't have to go update as an administrator. If you create a new service or delete a new service, this Kubernetes ingress controller is updating FortiWeb, and FortiWeb is having that security profiles already deployed, and you're taking care of that. So again, I want to show you how it looks on the FortiWeb really quick. Is this server objects here in the server pools. These are my different services here, but we see these are the ports, right? This is a node port that it actually created. The ingress controller created these objects, and it's obviously watching if something changes, it will automatically change these ports, and it will update it automatically again. So that's our Kubernetes and FortiWeb, or ingress controller FortiWeb.
Do you do anything further down into like the management API and protecting Kubernetes itself and the internals, and how do you capture information inside if they've got something like a Cilium or an Istio? Believe me, if you got Istio, you could probably barely find your own traffic, and you're sending it there. Let alone, we could use help with Fortinet.
Yeah, we're not doing any of that with the FortiWeb, right? This is more a layer 7 kind of application security product. We have like FortiGate. Aiden can talk more about like CFOS, which is more concentrated on those kind of use case, like monitoring this nodes, right? That's more.
I'm thinking, I guess, more like service to service traffic.
Service to service.
It's entirely possible if you 90% of people who say they're going to do MTLS but don't. Like, we've already got enough problems. Yeah. So that's quite often that's where the problems really occur, is internal service to service. And sort of because it's not external facing, that's what I'm just sort of curious where that.
Yeah, we're not doing service to service with this one. It's more
the outside.
It's more the.
Okay, great. Thank you.
Yep.
Can I clarify a few things?
Yeah.
The ingress controller that you've got, is that part of FortiWeb as a product, or can I actually use that ingress controller by itself?
Yeah, it is part of the product. So it's the agent of the FortiWeb, because when you create that ingress controller, the annotations are more FortiWeb related.
Got it.
Yeah.
Okay. And so FortiWeb was a virtual machine or an appliance, right? That's where that is hosted. Was that right?
It's a VM. It's hosted in Azure. Yeah.
And so do my applications need to be running in Kubernetes, or is this just an option if I've got applications that are running in Kubernetes? This is how you would do that, and I can still have other stuff off on functions or containers or web apps or whatever else, and that can still sit behind FortiWeb?
Yes,
Okay.
it can. Even if it's an serverless app, we have a few customers who are doing that.
Yep.
Serverless in Azure or applications running on servers. We don't. It doesn't matter as long as there is routing. This is always, I keep telling, as long as the FortiWeb is able to route the traffic
Yep.
and do reverse proxy for your application servers. It could be anything in the backend. This is just a use case,
Okay.
because it's Kubernetes has been everywhere.
Yeah.
for this,
Okay.
Yeah.
So you would only deploy the Kubernetes component if you're actually running applications in Kubernetes.
Right.
Right. Cool.
Either it could be a managed Kubernetes or AKS, EKS, anywhere.
No
Yeah.
worries. We've heard from a few other presentations in the last few days where their application is deployed in a managed Kubernetes cluster, and I was just trying to make sure that that's not a required component
No.
of FortiWeb.
Yeah.
It's an optional component if you're running Kubernetes workloads.
Correct.
This is
Yeah.
Cool.
Let's say FortiWeb is coming from the old school web deployments,
Mhm.
where you have a real web server and not fancy containers.
Yep.
But we can do that too.
Yep.
Yeah.
Yep. Awesome. Yeah, that's all good. Yep. Thank you.
So again, after when Julian is going to go over the SOAR, we'll show why the playbooks and everything, right? Why it created a GitHub issue. But going back, it took that alert attack log and it created the GitHub issue. This is kind of the Zoom thing, yeah. It took that attack log, right? And it's we also incorporated some open API here into this, but it's taking that information from FortiWeb attack log. And why Julian was blocked is because the FortiSOAR actually updated the policy on our FortiGate firewall that is going, that is actually getting to this application server with a blocked address, and it added the IP address automated object. If you see here, it was added earlier when it ran. So I just wanted to show that before we forget. Yep. So there is more about the FortiWeb and the ingress controller. So Julian, do you want to take over and show about FortiSOAR?
Yes, please. So let me automate you a little bit. So SOAR, I assume you already know what SOAR is, the security orchestration and automated response, right? It's a bit about automating the boring stuff, as I always say, bringing a bit more taking the time on the real complex things and removing that repeating tasks and all of that stuff. So, and Srija already started with machine learning, and we can do that too, especially on SOAR. And when we speak about SOAR and it comes to that whole topic, we use it as a central component. So SOAR is at the end the workplace for the security operations center. They get all the alerts in the SOAR. They can take actions based on that. They can correlate or they have to correlate information in there. They do incident handling. They set up communication maybe with different teams or interacting with different systems. And in the end, hopefully they close that issue and the problem is solved. And that's a bit of the central component in our case. And when we go back to our demo environment, now I will, at the end, complete that picture so that you get a better feeling of our architecture, what we did there. And so when we look in our first stage, what I did, and that's a bit of key, before I even can start securing my infrastructure, I need an asset. Aiden mentioned that already. I need to know about my assets, about the status of my systems. What do I have? Are they maybe vulnerable? And what's going on there? So that's one of the key takeaway or key pillars in that. And we leverage our cloud native protection solution, FortiCNP, for that, which allows me to feed in my AWS, Azure, and Google resources. Everything is on there. But besides that, and that's a bit of the important component, we're not only getting an asset list, we're getting also found vulnerabilities and maybe found issues, like, for example, Azure Defender for Cloud. It's detecting someone is trying to brute force my system, and by the way, you're missing some patches. Maybe you should take care of that box a bit more. That's exactly what we're also feeding in. So we know that box is maybe already affected by a known vulnerability or is attacked all the time. And we know that IP address earlier. And what we do with those information, because those information are great, but it's not all. So we want to classify it, for example, that IOC is that IP address which tries to connect to the box now the 5th time in less than 2 seconds. Who is that? Because maybe it's known from VirusTotal as a bad actor. And in addition to that, we get CVE IDs. We all know these fancy, shiny CVE 2023 numbers. Who of you can remember what exactly was that? So we need more details. We need maybe recommendations based on those patches so we can query NIST. And that's all an automated flow we do. So we feed in assets and, by the way, populating all the database. How does it look like if we switch directly to a SOAR? We have there the ability and the resources to have a look at the assets. And I get here a bit unspectacular list, but I have a view. I know the machines, I know where they are deployed. I have information about the IP addresses. If exist MAC addresses, not every machine in the cloud has a MAC address anymore. And also some more details. And if I have a closer look, for example, at my worker node, I get some more details. But if I scroll a bit down, I also know, yeah, it's a bit famous already on the internet. Someone has tried to brute force it. And I also know I missed some OpenSSH information. And besides all of that, I can look into the indicators and I see already IP addresses extracted from the brute force attack. So I have already my data and structure a little bit out and sorted. And if I look into these alerts, you'll see we did some testing before the field day event already, and you can see some attacks are happening against that system, and we see some code injection attacks. These are also correlated back. But that's why I need those asset information that I know what happened where and what exactly is going on. That's our first stage. The second stage, which was ongoing, is we need more details. We get an alert. That's great. But we need more information. What payload exactly was used? What was the attack of? That's normally not part of a basic alert. So we need to dive more. So what we did, we took that alert information and queried for our FortiWeb to get more details out of it, which is, in our case, relevant, and feeded that back into SOAR. What we then did with those information, because we have a huge amount of data and we don't have time, let's ask ChatGPT for that. Hey, can you correlate me this information? What does it actually mean? What is that? Give me a description. What MITRE attack ID is that? What technique do they use? What do I need to know? What is the indicator of compromise? All these details. We just used ChatGPT to query that. We could also have used Google Bard for both integrations for that to query them natively and just feed that back into our alerts. And if you have a closer look now into those alerts, let me show you that I cannot show you the status before because we indeed were a bit too fast. But if you look here, there's the malicious activity code injection. We have a little bit of a description. It's not that much, but it's enough. You maybe see a nice correlation because of that. We have the asset. We know that with that asset is something wrong. Some additional alerts happen to that. We get a MITRE attack ID. We get the indicators identified, and we get even more correlations as we know that asset. All this information, what you need and are required on that. And after that, we went to the third stage. We took those information, we said, hey, please, OpenAI, can you create us a GitHub issue text and evaluate those information which are relevant for that? What is the attack payload? What was the endpoint, for example? Extract those relevant information and provide it an open and GitHub issue for us. We used it and sent it through that GitHub issue connector. Same, we informed the developer as this was a high severe issue. We could do that depending on the severity of the alert. And even that, we informed the security operations center. And Srija, as our SOC, take action on the state 4, something the attacker didn't know. There's a firewall in between, and she just blocked it. Just blocked the IOC out of the network and say, okay, that's a bit of breaking that attack flow. We have for first aid help, we have a bit of silence. Now we can take care of and fixing those applications, because for sure, maybe also creating an IPS signature based on that is a great idea, and it helps first of all, but it's not a final solution. The final solution is always patching that application. That's how we did, and that's how we set up the whole infrastructure and deployment. Now, that's all great, and we get tons of alerts. We were speaking about alert fatigue. And exactly with that, and also visibility, we use on our FortiSOAR, we use machine learning. One big thing is, what about similar alerts? So we're learning what alerts are get it feeding into FortiSOAR. And we can, based on those information, we can correlate it. Hey, that IOC pops up quite often. First of all, we see it's attacking a web application. Next, it tries to brute force something. The other one, we see it changes registry keys on a Windows box. What's going on there? Usually, if you're sitting there in the SOC and you have your 5,000 alerts in front of your wall, you think, okay, well, where do I start today? And that's exactly the piece. So you start with one alert. And what it does with ML, it recommends you, hey, those 4 or 5 alerts look quite similar and have same indicators. Want to group them together as an incident? Maybe they correlate together at the end. But it's just a recommendation to get more visibility and to see a bit more of the bigger picture, what's going on there. Besides that, and that's also often you maybe stand there and, you know, great evening, 4 a.m. in the morning, 20 beers after the day, you get a nice call. Hey, we have an incident. What should we do now? And you say, oh, I have no idea. It gives you a recommendation. Hey, the last 400 times we worked on such a case, you did exactly that playbook flow. You executed those playbooks. That's how you can start right there, and you can execute those playbooks to take a remediation of that index, maybe enriching that alert, getting more information. It's a bit like statistics at the end. What can help you to make your life a bit easier? Besides that, one key thing is where SOAR helps a lot is phishing. Because phishing has often some key characteristics, and we pre-trained already various models for that we can easily identify it's phishing or not, and can sort it out and do auto-remediation on phishing attacks to just remove it out of the post box, for example, or the mailboxes from the employees.